In this video, I want to look at some important consequences of our 5 lemmas. The 5 lemmas are sitting in front of you, and to briefly review them, the first lemma says that if we're in a group and A triangle A is equal to A is the group identity element. The second lemma says that a right inverse happens to be a two-sided inverse. The third lemma says that the right identity is a two-sided identity. The fourth lemma says that the identity element is unique. And the fifth lemma says that inverses are unique. So I kind of want to put these together in an organized fashion. So let's think about this. If we look at lemma 3 and lemma 4, that says that the group identity element is unique and two-sided. Now, what this says is that if you happen to have a group, so if you know that G is a group, and you can show that, say, G triangle with A is equal to G, or you can show that A triangle with G is equal to G, either one of these is going to be enough to let you conclude that A is actually the group identity element. And it's usually traditional to write this group identity with just an E rather than an E sub R, since it works on both sides. If we go back and look at lemma 2 and 5, we see that we get a similar kind of result for inverses. So lemma 2 plus lemma 5 say that if we are in a group and A is an element of that group, then A has a unique two-sided identity, or rather a two-sided inverse element. Let me clean up my notation there. A two-sided inverse element. It's usually denoted by A inverse. And the consequence of this is that if you can show that A triangled with B is equal to E, or if you can show that B triangled with A is equal to E, either one of these facts will imply that B is equal to A inverse. So those are two very important consequences of our 5 lemmas. There's another really important consequence that I also want to look at. I want to recall that the book definition of group was slightly different than my definition of group. And let me clean up my handwriting there. So it's slightly different than my definition of group. And so it turns out that our 5 lemmas allow us to prove the following theorem. And I'm going to state this theorem really informally. But the 5 lemmas allow us to prove that the book's definition of group and my definition of group are logically equivalent to each other. And in order to actually look at why this theorem works, we really need to look at the book's definition of group and my definition of group, and we need to see them side by side. And I have that on the next panel. So here is the two definitions of group. And I encourage you to stop the video and copy this down if you want to. Although you've seen it before and it's not necessary to copy it if you don't want to. But I need to kind of refer to this in the proof of the theorem. So hopefully if you wanted to copy this, you stop the tape and you have now started it back up. What I want to notice, and I want to get yet another color, and let's see, I think this is a nice new color. I want to notice that the first two axioms are exactly the same. So there's nothing to look at there. Likewise, the second two axioms are exactly the same. So there's no problem there. The only difference in the two definitions are these two things that I wrote in red over here on the book definition. They are missing in my definition of the group. Now, what that means is that my definition of group is said to be weaker than the book's definition. Meaning there's fewer things that you have to show in order to claim said structure is a group. For my definition, all we have to do is show that the identity element works on the right, and all we have to do is show that the inverse element works on the right. In the book, you formally have to show the identity works on both sides, and you have to show that inverses work on both sides. So what I want to do is I want to notice, first of all, that the book's definition automatically implies our definition because our definition is a subset of this. In other words, if you just kind of ignore these two extra things, you have my definition of the group. So what I want to do is I kind of want to make that note. Since the book's axioms 3 and 4 are two-sided, they will directly imply my version of axiom 3 and axiom 4. So if G is a group under the book's definition, then G is a group. Let's see, let's get this back to where we were. G is a group under my definition. In other words, the book's definition of group implies my definition of group. That's the easy direction. We now have to look at going the other way. And I may have to come back to looking at this, but what I really want to do is I want to realize that we have to somehow realize that my definition is enough to get these two little red circled things, and our lemmas do that. So my definition implies the book definition. Well, first of all, as we've already noticed, axioms 1 and 2 are identical. So now what I want to do is I want to look at axiom 3. If I think about my axiom 3, which is that we have a right identity element, plus I look at lemma 3, which says that the right identity is a left identity. These two things together imply the book's axiom 3, which says that we have a two-sided identity element. So with our lemmas, my definition of group and the lemmas will give us axiom 3 in the book's definition. Well, if we look at axiom 4 in my definition, which is about right inverses exist, and we look at lemma 2, which says right inverses are two-sided, those two things together give us the book's axiom 4, which is that inverses are two-sided. And so what this means is that my definition plus the lemmas say that we get the book's definition of group. And of course, and let's see, I need to clean up my handwriting there. And of course, the lemmas only rely on my definition of group, and hence my definition, and I got to clean up my handwriting again. My definition of group implies the lemmas, and the two things together imply the book's definition. And as a consequence, what we can say is that my definition of group will in fact imply the book's definition of group. And consequently, it doesn't matter which of the two definitions that we actually look at and use. And so I want to go back and look at those two definitions for just one more minute. So here are our two definitions. The reason I prefer our definition is that these two axioms are easier to prove. There is less work to be done in order to show that something is a group.